The James Webb Space Telescope, a strong device from NASA, has been looking into the tremendous profundities of the universe, uncovering extraordinary discoveries. While it was previously centered around the investigation of smaller objects, its most recent revelations have shaken mainstream researchers. These discoveries are significant to the point that they could challenge our entire comprehension of the universe, convincing specialists to reevaluate our ongoing speculations and perhaps adjusting all that we believe about the universe. When we talk of the edge of the universe, we are often referring to the detectable universe, the part of the universe that we can see and concentrate on using telescopes and other advanced space tests. This domain contains galaxies, stars, and innumerable divine objects. However, the recognizable universe is just a small part of the whole universe. It's like a slice of a giant pie, one that we're just starting to explore. The true scale and state of the whole universe remain a mystery, and the detectable universe, though immense, is around 93 billion light-years across. A light-year, the standard measurement of distance in space, is the distance that light, the fastest known substance, travels in a single year. This distance sums to around 5.88 trillion miles or 9.46 trillion kilometers. So, when we say that the discernible universe is 93 billion light-years wide, we're talking about an enormous length that reaches back to nearly 13.8 billion years ago. This is when the universe began with the Big Bang, a gigantic blast that set the universe into motion. Since then, the universe has been expanding, and this expansion continues at an accelerating speed due to the mysterious impact of dark energy. Over time, matter in the universe has combined under the force of gravity, forming galaxies, stars, and planets, including our own Earth. Despite the vastness of the universe, much of it remains empty. If we could shrink the Earth to the size of a coin, the closest star would still be about the length of 2 soccer fields away. The void, in a way, grows within our own galaxy, the Milky Way, which is only one of billions of galaxies within the observable universe. This scale helps us grasp the immensity of space, which can be overwhelming to appreciate. You might ask why we can't see everything that exists in the universe. The answer largely involves light. Although light travels incredibly fast, it takes time to cross the vast distances of space. Therefore, when we observe distant celestial bodies, we are actually seeing them as they were in the past. The farther an object is, the longer its light takes to reach us, and it's almost like looking through a giant time machine. For example, when we look at galaxies millions or billions of light-years away, we are essentially investigating the universe's past. Additionally, the universe itself is expanding. Consider it like a blowing-up balloon. As the balloon inflates, spots on its surface move further apart. In the same way, as the universe expands, galaxies drift away from one another. This expansion stretches the light emitted by these distant objects, causing what is known as redshift, where the wavelengths of light become longer, making the objects appear redder. This phenomenon occurs because the space between the objects and us is accelerating, stretching the light, the expansion of space, and the ongoing development of the universe. It's no surprise that we haven't been able to observe everything the universe contains. Indeed, even with our most advanced telescopes, our view of the universe is still limited by these fundamental properties. The quest to understand the true boundaries of the universe has captivated scientists for a long time. Several competing theories have emerged, each offering different insights into the nature of the universe's size and structure. The first hypothesis suggests that the universe might be infinite, extending forever in all directions without a clear edge. This hypothesis aligns with the cosmological principle, which holds that the universe appears the same from every perspective. If this hypothesis is correct, the universe is boundless in every direction, without any limits to its scope. A second hypothesis offers an alternative viewpoint. It suggests that while the universe may have a boundary, it might not have a distinct edge. Instead, the universe could be shaped like a giant sphere or a curved space, meaning that if one were to travel in a straight line long enough, they would eventually return to their starting point, similar to how a trip around Earth would take you back to where you started. The third hypothesis, known as the multiverse theory, posits that our universe is only one of many. In this scenario, there could be countless other universes, each with its own set of physical laws and properties. These universes could be infinitely different from one another, or they could be connected through complex interactions, forming a much larger and more complicated multiverse. The James Webb Space Telescope, JWST, has been instrumental in providing insights into these cosmic mysteries. As NASA's latest tool for exploring the universe, the JWST is capable of looking deep into space with extraordinary precision. One of its most exceptional accomplishments has been the discovery of 6 massive galaxies dating back to only 500 to 700 million years after the Big Bang. These galaxies are significantly larger than expected for such an early period, testing recently accepted theories about the formation of galaxies. Their complex structures and immense sizes suggest that galaxy formation could have occurred much more quickly than previously believed. The JWST's ability to capture infrared light, which is invisible to the naked eye, allows it to detect faint signals from ancient stars and galaxies. This ability is akin to a time machine, offering a glimpse into the early universe. The telescope's discoveries have revealed galaxies that seem to defy our past understanding of cosmic evolution, suggesting that they may have formed much faster than expected after the Big Bang. These galaxy breakthroughs challenge the hypothesis that galaxies form gradually over time. Traditional models suggested that galaxies start as small, simple collections of stars that slowly evolve into more complex systems. However, the JWST's findings have shown that some galaxies appear fully formed much sooner than predicted. This has forced scientists to reconsider the process by which galaxies grow, particularly considering how such large, complex galaxies could form so rapidly after the universe's origin. The data gathered by the JWST also uses spectroscopic techniques to study light across various frequencies, revealing further details about these galaxies, such as their structure, size, and distance from Earth. By analyzing the light emitted by these distant galaxies, scientists can piece together the history of the universe itself. The new discoveries from the JWST have revolutionized our understanding of the universe, revealing a more complex and diverse cosmos than we had ever imagined. The revelations made by this exceptional telescope not only challenge existing models of galaxy formation but also offer exciting new possibilities for how we might interpret the universe. One of the most significant breakthroughs is the identification of the oldest and most distant galaxies ever observed. These galaxies date back to when the universe was still in its infancy, just a short time after the Big Bang. These discoveries highlight the JWST's remarkable ability to peer far back in time and study the early stages of the universe. Despite the incredible discoveries made by the JWST, much of the universe remains hidden from view. There are still vast stretches of space that we have yet to explore, and even with the JWST's cutting-edge capabilities, there is still much to learn about the universe's history and future. The telescope has provided us with a new window into the universe. However, there is still much more to uncover. As we continue to explore the universe through the JWST, we are reshaping our understanding of the cosmos. The telescope's groundbreaking discoveries are challenging our established ideas about the universe and prompting us to rethink fundamental questions about its origin, structure, and ultimate fate. The discoveries made by the JWST will undoubtedly have a lasting impact on our knowledge of the universe for many years to come, offering new insights into the nature of space, time, and the universe itself. The James Webb Space Telescope continues to surprise the academic community with its historic discoveries, providing humanity with an extraordinary exploration of the depths of space. As we uncover more details about the early universe and its development, the JWST is playing a crucial role in transforming our understanding of the universe. Its ability to observe distant galaxies, stars, and other celestial objects in greater detail than ever before is unveiling secrets that were previously beyond our reach. What makes these discoveries even more significant is the JWST's ability to provide a window into the very beginnings of the universe. By capturing light from galaxies that formed only a few hundred million years after the Big Bang, it allows us to study the early stages of cosmic evolution in real time. This opens up a whole new range of possibilities for understanding the formation of the first stars, galaxies, and other structures that would eventually lead to the universe we know today. One of the most fascinating aspects of the JWST's discoveries is its ability to reveal the true scale and complexity of the universe at an early stage. The massive galaxies that have been found, many far larger and more complex than expected, challenge the traditional view that galaxies evolve slowly over billions of years. Instead, we are now faced with the possibility that these enormous structures may have formed rapidly in the early universe, suggesting a much more dynamic and intricate process of cosmic evolution than previously thought. This newly discovered complexity pushes the boundaries of current scientific models and forces us to reconsider our theories about dark matter, dark energy, and the forces that shape the universe. As we learn more about the rapid development of these early galaxies, scientists will be required to revisit how we understand physics, especially the behavior of matter and energy in the early universe. The JWST is providing the tools necessary to explore these fundamental questions in ways that were previously unimaginable. As we continue to probe deeper into the early universe with the help of the James Webb Space Telescope, JWST, we are encountering new complexities that challenge our traditional models of cosmic evolution. The discoveries made by the JWST are offering unprecedented insights into the formation of galaxies, stars, and other celestial objects. These findings are reshaping our understanding of the universe's early stages and its subsequent development. One of the most compelling aspects of the JWST's findings is its ability to observe distant galaxies in greater detail than ever before. These galaxies, which formed only a few 100 million years after the Big Bang, are revealing a much more intricate and dynamic process of galaxy formation than previously imagined. The sheer size and complexity of these early galaxies suggest that the universe's evolution might have occurred at a much faster pace than we had thought. This challenges the long-held belief that galaxies form slowly over billions of years, gradually evolving into the massive structures we observe today. The discovery of these early, massive galaxies has profound implications for our understanding of the universe's formation. It suggests that the building blocks of galaxies may have come together much